Hey, what's up? Oh yeah, definitely. Yeah. So 2 very easy questions, and we're gonna test to see, if you're smarter than 5th grade, right? So the first one, have 3 water bottles, and I filled them halfway with water.
Okay.
And I painted the water blue with food coloring just to make it easier to see.
Okay.
So, by the way, all of these water bottles are at rest. You know what that means, right? They're still. So, how I'm showing them to you, what's the difference between these 3 water bottles?
What's the difference between these three water bottles?
Yes.
This one is upside down.
Yeah, I didn't answer. It's like this.
This one is like this.
Oh, here.
And that one's
right side up. Yeah, you got it. How did you know?
Just because the way the water was.
The orientation of the water, right?
Yeah.
Relative to the bottle.
Right.
Obviously, because water can't stick to the side like that. That defies physics. Right? It's obvious, right?
Yeah.
You got it. Pretty easy. So the second one, similar, but this one I have a box truck halfway filled with water again.
Okay.
But in this one of the trucks is accelerating forward.
Okay.
One of them is accelerating in reverse, and one of them is at rest. So which one is at rest?
This one's at rest.
How do you know that one's at rest?
Because I know that this one before, because the car goes back when you like go forward, and when you're going backwards, the car will lean forward.
You're talking about like the water will push back.
Yeah. So like I know this one's at rest because it's level.
Do you think if I told you that this one's actually accelerating, would you believe me or not?
No.
No, right? That defies physics.
Yeah.
Exactly. It's like when you accelerate in a car, you always get pushed back to your seat.
Right.
Always.
Right.
So claiming that doesn't happen,
yeah,
that defies physics, right?
Yeah.
So let me ask you this: do you believe objects accelerate down in free fall because of gravity?
Accelerate down.
Or do you think objects move towards the ground? I guess in free fall.
I think they accelerate down. Yeah.
Right.
I think the longer they're falling, the faster they're gonna move. Right.
So again, it's the same principle. The water always pushes back in the opposite direction you accelerate.
Exactly.
So when I accelerate this bottle down, actually accelerate it, the water wants to push up.
Exactly.
It displaces, right?
Exactly.
In reality, when we put it into free fall, my phone's overheated, but when we put it into free fall, that displacement doesn't happen.
Right.
So that shows us that this bottle's not being accelerated.
It's not actually accelerating.
So it's the Earth that's moving up. So the Earth right now is pushing up against you. Gravity as a pulling force doesn't exist. So you're not being pulled towards the Earth.
You're
the Earth is pushing.
Up.
Exactly.
That's
So
interesting.
so let's say hypothetically the Earth is moving up at 100 miles an hour right now. While I'm holding this is also moving at 100 miles. The instant I release it,
it's not
accelerating.
Yeah.
It's not moving it at that constant speed.
Yeah.
It starts to decelerate.
Yeah.
So it's the Earth that comes up to me.
Right.
So that's why Einstein, I don't know if you've heard of Einstein's theory of relativity, he acknowledges that there is no force in free fall. So he came up with his mind-bending explanation of the bending and warping of space-time to explain how objects still accelerate down without actually accelerating.
So when I jump, I'm jumping and the Earth is coming back up.
Exactly, man. You get it, man.
Interesting.
So you've heard of flat Earth, right?
Yeah.
Flat Earth is a psyop, and I'm gonna tell you why. Flat Earth and globe Earth are the exact same thing because over 95% of flat Earthers claim the Earth is motionless. So they
honestly, I think the Earth is flat, but I don't think it's just like this. I think it's
it's a topographical plane.
I think it's it's still flat, it's still two-dimensional, or not two-dimensional, but it's not a full globe. It's like a circle that's kind of bent.
Okay, so here's my thing. Obviously, in my opinion, the Earth is not flat because you could have a flat wall.
Right.
That does.
Right.
The Earth is level, and I'm gonna tell you why. Because the Earth has orientation, and in order for something to have orientation, it needs to be moving. So the Earth is level relative to the vertical, which is the Earth's motion. So everybody's up, everybody's vertical is perpendicular. It's all parallel. You know what I'm saying?
Yeah.
So again, these motionless flat Earthers, again, by default, they're claiming also that there is a magical acceleration in free fall that doesn't displace the water. That kind of acceleration doesn't exist.
That makes sense.
So again, that's why gravity is always going to be a theory because gravitational field that's pulling objects to the ground doesn't exist. So
that's dope.
So yeah. So if we could prove that it's the Earth pushing up, how would that work from a globe?
It wouldn't necessarily work.
Exactly, because that would mean the Earth will have to be growing and it will have to be pushing up in all 360 degrees.
Right, whereas it can only push up in one direction.
Exactly.
Because if you're on the bottom of the Earth,
how can it push down?
It can't push down up at the same time.
Exactly. So that's the biggest lie on Earth, that objects accelerate in free fall. And flat Earth, that's how they're controlling it. They claim that objects accelerate down too. That's where the motionless flat Earth comes into play.
Interesting.
That's the psyop. So stay away from those people.
Yeah.
That's all mainstream flat earthers on YouTube. They all talk about a motionless flat earth. So they're just debating an idea with globe earthers that's not going to go nowhere.
Yeah.
So, man, I'm glad you stopped, man. I really appreciate it. Here's my information. Here's my channel. Sure. Take it with you.
Okay, cool.
And yeah, man,
okay,
thanks a lot, man.
Okay, cool. Thank you.
Yeah, take care.
Fifth grader.
Are you?
I hope so.
Yeah, you are. You want to give it a shot?
Yeah, I want to try it.
All right, 2 very easy questions. All right, so we'll start with the first one here. Okay. So in this one, I have 3 water bottles and I filled them halfway with water and I painted the water blue with food coloring just to make it easier to see. Another thing about these water bottles is that they're all at rest. So how I'm showing you these water bottles, what's the difference between them?
Which way the water is.
Okay, so what's the difference between the water bottles then?
There is no difference. They're all the same water bottles.
Okay, I'll tell you what then. I took the water bottle in 3 different orientations. I took a picture of the water bottle in 3 different orientations. Can you put them in the orientation they should be? Or in the orientation I took them?
What do you mean by that?
So I took a picture of my water bottle like this. I took one like this. And I took one like this. So out of these 3, which one is the one that I took holding upside down?
This one.
One, right? Yeah, you got it. And how did you know that?
Because of gravity. How gravity
Right,
works.
it's how the water is being displaced, right? The water goes to the bottom, not the top. So logically, I took it like this. And then obviously this one is the one I took sideways.
Sideways.
Exactly, again. So again, it has to do with the orientation of water when it's here on Earth, basically. Right? So the second one, similar, but in this one I have a box truck halfway filled with water, but in this one of the trucks is accelerating forward, one is accelerating in reverse, and one is at rest.
Okay.
Which one is at rest?
B is at rest.
Why do you say B is at rest?
Because it's not doing, the water's not doing anything.
All right, perfect, yeah. And which one's accelerating forward?
A is accelerating forward.
And how do you know A is accelerating forward?
The water's going backwards.
Right, so when you accelerate a container with water, the water always pushes back. Right? So yeah, exactly. So the real reason I'm doing this is, do you believe, like if I was to tell you B is actually accelerating, would you believe me?
Yeah, I could believe that.
You could believe that?
Yeah, probably.
Why would you believe that? Can you, because every time, because for example, when I have a container with water and I accelerate in any direction, it doesn't matter the speed. If I go from at rest to acceleration, that displacement always happens.
Right.
So to be able to accelerate this and the water staying level, that defies physics. Would you agree or disagree? Or do you think you can demonstrate acceleration without the displacement? Nah, right? It's obvious because water is a fluid. You know, it doesn't have a form, so it's always going to displace when you accelerate, right? Let me ask you this. Do you believe objects accelerate down in free fall? By a pulling force like gravity?
I would say so.
Yeah, so based on these principles that we understand, when I accelerate this bottle down, the water wants to push up, again, the opposite direction. But in free fall, that doesn't happen. The water stays down here because there's no force acting on it. Therefore, this is not accelerating down towards the Earth. So what's happening is the Earth is actually pushing up against you right now. It's not pulling you down to it. So it's the Earth's motion, and then as soon as I release this, it starts to lose that motion. So it starts to lose its velocity, and the Earth catches up to it. So gravity as a pulling force doesn't exist. And how do we know that? Again, because there's no displacement, there's no inertia of the water pushing back, you know, in the opposite direction that this supposedly accelerates. You know. So again, that's why gravity is just a theory, and it's always just going to be a theory because objects don't move down towards the Earth. It's the Earth that moves up to the object. So if we could prove that physically, how would that work from a globe if the Earth is pushing up on you and not pulling objects down? It wouldn't work because if you're in North America, if the Earth's moving up, how would the Earth be moving up or down in Australia? You know, it would have to be growing. It would have to be pushing up in opposite directions, which wouldn't work on a globe.
You know a lot more than I do. So.
No, yeah. So this is the number one proof that debunks the whole globe Earth is that objects don't accelerate down in free fall. You know, so the whole globe Earth concept is based on a false premise, which is that gravity is a pulling force. You know, I'm assuming you guys believe in gravity as well as a pulling force. Exactly. Yeah, right. If I was to ask you guys, why do you guys believe that?
Because when I jump up, I come back down.
Have you heard you heard of inertia, right? It's a resistance to change in motion, right? So your body is trying to resist the motion that we're already experiencing here on Earth. So when you jump, you start to lose that momentum as soon as, you know, when you jump, you're adding an extra force up. and then you start to lose momentum automatically. So that's why the Earth catches up to you again. So you're always moving up. You never came back down.
The Earth is catching up to me.
Catching up to you, because as soon as you're not connected from the Earth, after you jump, you start to lose momentum because of inertia. It wants to remain motion. Your body wants to remain motionless. So the Earth just simply catches up to you.
Pretty sure that's not how inertia works.
Inertia is resistance to motion, or change in motion.
Yeah, it's resistance to change in motion. So
Yeah.
if you're moving, inertia will say you should keep moving. Right?
Exactly. So you're saying like perpetual motion. So you're saying perpetual motion has never been demonstrated or proven. So
Yeah, but inertia doesn't require perpetual.
no,
It's just
an object at rest will remain at rest, but then they also say that an object in motion will stay in motion. But that part is not true. An object always wants to remain at rest. In other words, motion.
Why is that?
Because of inertia, there is something causing matter to just because inanimate matter cannot move on its own.
Then why
Would-
is the universe expanding at a faster and faster rate?
Well, that's just a theory that outer space is a. Oh no. The Earth is an enclosed system because you can have two opposing pressure systems next to each other without a barrier. That's the second law of thermodynamics.
Is the expansion of a gas into a vacuum. I have in one of these bulbs some bromine, and in the other I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy.
So they're claiming outer space is a vacuum next to Earth's pressurized system without a solid barrier separating the two. That defies physics. So again, the Earth is a contained system that's pushing up on you.
If it's pushing up on me, and there's someone in China that's on the opposite
Well,
side.
the Earth is not a globe. The Earth is a level plane. So everybody's up is the same. Your up is the same as up as Australia.
We're flat earthers?
And the Earth is not flat, by the way. Flat Earth is a psyop. Because they actually believe the Earth is motionless, so they claim that there is a magical force like gravity accelerating things. That's the psyop. The fact is, it's the Earth pushing up. So over 95% of flat Earthers claim the Earth is motionless, which is no different than the globe.
So you're saying the Earth is...
A level plane, and level is an orientation. And in order to have some orientation, you need motion. So the Earth is level relative to the vertical, which is the motion of the Earth.
It's not a globe?
It's not a globe. It's a level plane. It's an extended plane, and it's an enclosed system. I've never been to the wall of this container, but there is Antarctic treaty that prevents people from exploring the Earth. There's a lot of treaties that keep people from exploring the Earth, so nobody will be able to actually find it.
Have you ever flown around the Earth?
North to south navigation has never been done, which will technically kind of prove a globe, right? But north to south navigation, coming back to the north again, has never been done. Only east to west, supposedly, which could be done on a level plane. Yeah.
All right. Well, unfortunately, our car is here.
No worries. You have any questions before you go?
Yeah.
You want to? Yeah.
Thanks. Get a pamphlet. Get a pamphlet.
Yeah, get a pamphlet. Here you go.
Thank you.
Yeah, no worries. Take care.
How do you explain photos? I think photos from space.
Yeah, and, NASA admits they're all composite images. So they say they take strips of imagery and they put them together in a Photoshop.
Okay.
So they're not real, basically.
Thank
Yeah.
you.
All right, no worries, man. Take care.